In this lesson, we will review some techniques to solve equations. We will specifically take a look at equations that you might encounter in your Intro to Chemistry classes. Let's begin. Our first example is D equals m over v, and in part A we're going to solve this for m. In part B we'll solve it for v, or volume. And in part C, given units for density and units for the mass, we'll determine the units for volume. So of course you may have recognized this as your density equation. Density equals mass per unit volume. So in part A we want to solve this equation for m. Now, even though there are several variables, and in a typical math class you might be more used to seeing something like, let's say, 2 equals x over 5, where you have only one variable, all the rules you have learned in that class that apply to solving equations still applies when you have several variables. The only thing is, m is what you're solving for, so you're going to treat m as your variable, so everything else can be regarded as a constant. So do whatever you would normally do to solve an equation in one variable. So in this situation, you would multiply both sides by 5, right, to solve for x. So basically this equation is no different. To solve for m, you need to get rid of the division by v, and we'll do that by multiplying both sides by v. And we'll do that in the next screen. So here we have d equals m over v. We'll multiply both sides by v. So the v's cancel, and we have our answer, m equals v times d. Okay. And in part B, we're supposed to solve the same equation, but this time for v. So let's begin with the same equation. And the first step will still be the same, even though we're solving it for v. First, it's good practice to try to get rid of the denominator. So we'll multiply both sides by v. So once again, the v's cancel. So what we have is m equals v times d. And now, to solve for v, we can divide both sides by d. So divide by d. Divide by d. So now the d cancels on the left-hand side, and we're left with our answer that m equals, rather v equals m over d. So that is our final answer there. And in part C, we're supposed to place the units and determine the units for the volume quantity, given that mass is in grams and density is in grams per liter. So how do we determine the units for the volume quantity? So again, we begin by substituting for mass. We substitute grams, and for density, the given quantity was units were grams per liter. So now what you have is you're technically dividing by a fraction, and there, let's remind everyone that you write your numerator as it is, and you multiply this by the reciprocal of the denominator, which will be L divided by G. And at this point, we can simply cancel the G's, and we're left with L as our final units. As you would have expected, units for volume. If the given quantities are in terms of grams and grams per liters, the units for volume turns out to be in liters. Okay, let's take a look at our next example. Again, this one might be familiar for some of you. This is the equation that you use to convert from Fahrenheit degrees to centigrade or Celsius temperatures. In part A, we're going to use this equation to solve for T sub F, or temperature in Fahrenheit. And in part B, we'll determine the Fahrenheit equivalent of 40 degrees Celsius. So let's begin by multiplying both sides by 9. Once again, if you have a denominator, that's usually a good idea to try to get rid of that. So we'll take the given equation and just multiply both sides by 9. So the 9's on the right-hand side will cancel because there's a multiplication between 9 and 5 9's, so they can be canceled. So what we're left with is nine times T sub C equals 5 times quantity T sub F minus 32. Now further, to solve this for T sub F, we need to get rid of this 5, which is being multiplied with this quantity. So to get rid of that, we're going to divide both sides by 5. So let's divide both sides by 5. So now the 5's cancel, and we have t sub f equals, actually, let's do that in the last step. So we have on the right-hand side, t sub f minus 32 equals 9/5 times t sub c. And any ideas how we can finish this question to solve for t sub f? You would need to add 32 to both sides, right? And you will have t sub f equals 9/5 t sub c plus 32. So when we add 32 to both sides, negative 32 plus 32 will cancel each other on the right-hand side, and it only appears on the left-hand side as plus 32. So there we have it. T sub f equals 9/5 t sub c plus 32. Of course, I could have also written it as follows. T sub f equals 9/5 t sub c plus 32. And as to part B for the same question, determine the Fahrenheit equivalent for 40 degrees Celsius. So all we have to do is plug in 40 for our T sub C, and we'll get the Fahrenheit equivalent for that. So T sub F equals 9/5 times 40 plus 32. Again, you could plug this in your calculators, of course, but the numbers are simple enough that we can simplify and do it without a calculator. Like 5 goes into 40 8 times. Then we have 9 times 8 is 72 plus 32. So we're getting 104 degrees. And the units would be, this would be in your Fahrenheits. Okay, so let's move on to another example on solving equations involving formulas. Okay, here we have A equals B times H over 2. This, of course, is your formula to find area of a triangle, right? Base times height over 2. The questions we're trying to solve this equation for H. So once again, since we have a denominator of 2 in the equation, you may want to clear that out first by multiplying both sides by 2. So let's multiply both sides by 2 on this side and by 2 on the other side. So the 2's will cancel on the right-hand side. And what we have left is 2 times A equals B times H. We're trying to solve for H. So any thoughts on what we should be doing next? If you said divide both sides by B, you are correct because we're trying to isolate H by itself. So we're going to divide both sides by B. And the answer is, after you cancel the B terms, rather the B factors on the right-hand side, you have H equals 2A over B. And you can, of course, rewrite that as H on this side equals 2A over B on the other side, which is typically how you would leave your answers. Okay, moving on to another example. Something you might see in chemistry or in physics, kinetic energy, or Ke, equals 1/2 times mv squared. The question is to solve for m. Again, at this point, I would highly recommend that you would pause the video for a few moments, work out these examples on your own, and then come back and see the solutions. And assuming you've already done that, let's go through the solution. So solving for m, since we have a denominator of 2, it is somewhat similar to the previous example. I will begin by multiplying both sides by 2. So let's take the given equation and multiply both sides by 2. So on this side, the 2's are going to cancel. And what we have left is 2 times kinetic energy equals mv squared on the right-hand side. Again, remember that we're trying to solve this for m. We're going to need to get rid of this v squared that is being multiplied by m. So to do that, we need to divide both sides by v squared. So divide this side by v squared and that side by v squared. Again, the v squares cancel. So our answer will be m equals 2 times kinetic energy divided by v squared. So once we clean out the v squares on the right hand side, which already canceled, that's the answer as we see. All right, next example is an equation you might see in chemistry when you're studying gases. And this is an abbreviated version of a formula that you might see there. So pressure 1 over temperature 1 equals pressure 2 over temperature 2, or P sub 1 over T sub 1 equals P sub 2 over T sub 2. In part A, we're going to solve for P sub 2. And in part B, we're going to solve for T sub 1. Okay, for solving for P sub 2, this is what you're trying to isolate from everything else. That means you just need to get rid of this quantity. And how can we do that? Since P sub 2 is being divided by T sub 2, to get rid of it, like we've done in the last few examples, we need to multiply both sides by T sub 2. So let's begin with that equation. And I will multiply both sides by T sub 2. And T sub 2's on the right-hand side are going to cancel. And already we have our answer. P sub 2 equals, and here's written out a little bit neater, P sub 2 equals T sub 2 times P sub 1. Of course, you can write those in any order because they're being multiplied because of commutative property of multiplication. So P sub 1 times T sub 2 divided by T sub 1, which is really what we had over here. That just looked a little bit different. But you can assume there's a 1 under this, and multiply the tops, multiply the bottoms, and that will give you this final answer. Okay, what about the second part, part B? That one is a little bit more challenging. We're supposed to solve for T sub 1. Okay, now you could technically multiply both sides by T sub 1 times T sub 2 to clear this equation from all the fractions. However, that gets a little bit messy, or there is an easier way which I'd like to make sure that you guys know about. I know your science teachers are going to use this, which is a cross multiplication method, and hopefully you've already seen that. So let's take our original equation and we're going to do cross multiplication. And you can use this anytime you have a single fraction on the left-hand side and a single fraction on the right-hand side. Then you can basically say that the product of this times that is going to be equal to the product of this times that. So rewriting what I just said, P sub 1 times T sub 2 equals P sub 2 times T sub 1. So that way, in one simple step, you have cleared your equation from any fractions, and you have something easier to work with. And the next step is to solve for T sub 1. And all we have to do is to isolate this. We're going to get rid of the P sub 2. That means divide both sides by P sub 2. And that's all we have to do. We have our answer. T sub 1 equals P sub 1 times T sub 2 divided by P sub 2. Okay, so there are a few more examples I'd like to go over with you, but I'm going to save those to the second part of this video. So if you need more practice on solving equations, make sure to look for the second part of this video series on solving equations.